Hey again, it's me. I'm wearing my best Tuesday flannel. Um, a lot of people have asked me about the 3D filament loader. I've had a ton of questions online. One of them was, okay, I downloaded it, I printed it, and now how do I put it together? So this video is going to be a little long. You're welcome to fast forward through it, but if you want to actually see everything I did to put it together, I've printed it several times. It doesn't really matter the quality because I clean it up with a file anyway, or a series of files, because I want it to work a certain way, and there's a fair amount of fitting to it to make it work right and not jam up. So I'm gonna go ahead and stop this camera, and I'm gonna start the other one on my workbench, and I'm just gonna put one together. You'll see it from the start to finish, from coming off the printer till it's put together, and then I'll stop the video so I can assemble or put the one I'm gonna assemble on a extruder, and I'll run it through some tests, and you'll get to see that when it's all done. So till then. So on the workbench, you're going to see a bunch of tools. Obviously, this is everything I use to clean up on my 3D prints. I love these files. They're from Harbor Freight. I think I paid $10 or $12 for the whole set of them. They're diamond needle files. They work fantastic for PLA, ABS, just about every 3D filament I've used. Anyway, that's my primary tools. Obviously, I have some other things here. Again, I'm a big fan of Harbor Freight. I hate to say it, but I use their light-duty moldy tool, or moto tool, if you will, Dremel tool. Over here I have a bunch of different drill bits and various Dremel accessories, hobby knife, and some bits of brass. I'll show you how that goes together, or where I use. There's a small piece that gets used in one piece of this. So again, apologize, this video is probably going to be a little lengthy. Feel free to fast forward through the areas that you don't I'm going to go ahead, and obviously this is the parts of the filament printer, or filament runout, or filament device, if you will, that loads a fresh supply of filament. I hate to say roll, because if you have a small piece and you just want to use it up, then put that piece in, as long as it's the same filament or it's what you want to use for the existing print. But as you can see, this is obviously fresh off the printer. I'm just going to start putting it together, and I'm just going to let the video run while I'm doing it. As you can see, the pieces, I didn't take a whole lot of time to calibrate for this particular filament. I printed this in ABS in white, and it is, what brand did I use? I can tell you, it doesn't really matter. Anyway, so the one thing I did do, and I forgot to mention in the earlier video, is that it's actually printed at 100% infill. I wanted the parts to be as strong as possible and hold up. Two supports I use in the whole thing is one right on the front piece, and they just and again, this video isn't about how to print something. That, I think you guys know plenty, that you're learning how to print. This is about making this device that, and if I could hang on to it and not drop it, how to make this device to improve your chances of not losing a print for your filament running out. And from time to time I use various drill bits to clean up openings and holes for areas that everything on this device is put together with 3mm screws, so obviously I just most of it is for most of the pieces. I'll just literally give it a quick going over on some of the surfaces that didn't print as smooth as I like them to. The mating surface is where this piece will attach to the other, because this is the channel right here where the filament goes down into the extruder itself. So you want to make sure that's nice and smooth. Where the entranceway is, you just want to make sure there's no burrs or pockets that keeps it from going in there smoothly. And like I said, I just basically go over the whole thing. Sometimes I'll just dress it lightly with a file, a small file. Other times I'll pick up a larger file and just smooth it off. And as long as it's nice and true, even though it doesn't necessarily need it, I often run the file on all the surfaces just to square them up, because every printer is different, and it also eliminates the need to try to make a pretty part. And I change filaments a lot, so I don't, certain things I don't need that kind of detail. I just need it to work. So just a little cleanup here and there. Now, the one thing I also didn't show, or another thing I didn't mention, is in a lot of cases for the screws that I use to bolt things together, some of it doesn't really need to be strong, it just needs to be on there. So I'll go ahead and use a drill and a small tap, and just tap it out for the 3mm. Again, love these little drill taps. You can get them at Harbor Freight for about $10. You can get a whole set of metric, a whole set of English, or what is it, SAE. And I basically just tap out the parts, clean out the opening. And this part is just about ready in the whole assembly. So just pop in one of the nuts. Those should pop. I do, and you've probably all learned. Let me grab a long 3mm screw. If you're having trouble getting your nuts to seat properly, and it's better to have them tight than loose, I'll actually put the nut on the end of a long screw, and then use a small torch, heat it up a little bit, and then just pull the nut down into position, and it'll seat into the bottom of your pocket and actually lock it in place. So it's a good tip if you're it's actually better to make those pockets tight than loose, because then things don't move around as much. But these, you can see I sized them pretty well, so they really didn't need to be heated up, but it works well if you haven't done that. So this piece is almost done. I mentioned that there's two small pieces of Bowden tubing that's used on this device, and one of them is down inside, and it comes down through the hole in the main body of the unit. The other one is just to make a little guide, and for that one, it's the only screw of this length, and if you give me, it's in the list of parts that I listed on Colts that shows exactly what it is, or what all the lengths are for the various pieces. But of the two pieces of Bowden tube, they're roughly the same length. It's basically, I just took a piece of Bowden tubing and I drill it out for the diameter of a 3mm bolt. So it just pretty much slides in there. My screwdriver, and I just run it down through it. And all this is to make a guide so that it's less friction, and then this just screws onto this guard, and it'll see it when it all goes together later, how that interacts with the filament. So now that that's in there, this piece is done. Set that aside. There are two slide stops I included because I have two different types. I have one on the Bowden tube setup, and I have another one on a direct drive unit on my Ender. The reason being is if you have a Bowden tube setup, you don't need to have the extra little guard. But as you can see, this is all the cleanup I'm doing on these parts. I just knocked the high spots off just to make a functional part. And again, I could take a lot more time, make the holes exact size that the screws go through, but different settings on different printers, these holes aren't going to come out the same for everybody. So in my opinion, it's just easier if you have the right size drill bits that match up for those screws, just go ahead and clean those holes up. So I'm just going to keep jumping back and forth with the tools. My feeling is that if you're buying this, or if you're watching this video and you're making this device, chances are you've got a decent amount of experience in cleaning up prints. So anyway, so where's the part I was just working on? There we go. So these, because the bolts just go through these, I'm just cleaning up the openings. So that part's done. going to go through these one by one. This is the same part, or it serves the same purpose as the other filament, or the slide stop, except this one is designed to work with the one I have mounted on the direct drive, and you'll see why I use this, or I'll explain it when I do the final assembly. Now on this one, there's a notch in the front, and again, depending on your printer, your settings, this slot. I just have a piece here. Obviously, as you can see, it won't fit in there yet. The reason for this is when you feed a new piece in on the direct drive, the direct drive is going to be moving around a lot. The filament that's obviously on the spool down through the feed rollers, that is under constant, it's held in place very well. The next piece coming in is only held in by the spring tension of the device, so this piece of filament is going to be moving, as the head moves around, or as the print carriage moves around, this filament's going to be pulling all over the place. So I need it to stay over the printer, but I also need an easy way to get it in there. So that's the reason for the slotted notch right here. And I'm just going to, since I printed it really quickly last night at a high-speed setting, I didn't really pay much attention to the amount of material that was being laid down. I just basically take a file and I open it up until it gets to be wide enough to slip a piece of filament through. Smooth it up. And if you're wondering why it's angled, that's because as it's feeding down through the printer, you can load it on a slight angle, but then once it's standing upright, it won't slip out and it'll stay in this vertical position. As you can see, if I slip this filament in now, and it doesn't come out because it's always going to be moving like this, but if I need to take it out or add a new one, I can just feed it into the unit and then click it in place and it stands upright. So that's the purpose for this piece. So I'll set that aside. That can made up with, or sit there with the other one that's already been set up. Just some other pieces. This one needs very little cleanup. This is one of the lower lugs that holds it to the millimeter screw going through it. And I just clean that out. And I just like to dress them up because, like I said, this print was a little rough because I printed it way faster than I normally wanted to, but I wanted to get this video out. So just a couple of moments with a cleanup. And if you saw the picture of how it was laid out on the build plate, that seems to be the fastest, the most efficient way, and the strongest for the grain structure of the filament. If you printed the main body vertically, of course, it's obviously going to be the weakest. If you lay it out the way I showed it, it is pretty much the best way. So pretty much that's all I got to do to this piece. Same thing goes for, this is the actual plunger. This is the one, well, we're gonna wait on this one and the main body because that's the most critical fit and finish in the whole thing. The other one, here's the other lug that bolts it to the underside or I love these files. And they don't wear out. A lot of this is just for aesthetics. It doesn't need to be this clean, doesn't need to be this smooth. Just cleaning it up a little bit. Okay, so that piece is done and ready. Next is the actual slide itself that goes up and down on the main body. Again, just a little bit of cleanup needed. Lock the little high spot. You guys probably spend a lot more time getting your printers calibrated to give you perfect print surfaces. I'm more of a mechanical guy. I just want to make working parts or functional parts, so the appearance isn't as critical to me, but obviously I would love it to all print out beautifully, but in practical sense, I don't want to spend that much time getting everything looking amazing. I just need it to work and be strong. Okay, so this one needed very little cleanup. This hole sits here is just to give a place for the tap to go, because I'm going to put that tap and I'm going to run it down in that opening as well. So here's another mating surface that needs to be nice and flat, because this is where the swing arm that interfaces with the filament has to move. Here for one purpose is when this little swing arm is here, it keeps it from rotating all the way around. It's just a stop. So to clean that one up, I like to go to the small Dremel or small moto tool and just and then the last piece of this is, because it has to move smoothly on this body, as you can see it slides on, but it's pretty tight right now, is I usually take a large flat file, just because it's the easiest thing to use, and just give it a quick do the same thing on the body, just a couple of was on the build plate. I do like to finish this with the small flat needle files, because they have a much better surface, and just run it back and forth, knock the edges off if there's any to deal with, true up the top, and then just go over every surface. It just cleans it up. So you can see it didn't print too bad. I probably have a little bit over extrusion right on the face. So again, if I've got a little extra, I'll just take the big flat file and... Oh, my light's about to go out. That's better, a little brighter. Give that a little quick going over. A little bit here in the mating surface. Just true it up nice and square. And then I'm just going to clean up my logo, because resin, it came out way nicer. Again, this is what tells me I have too much over extrusion. This should say Plastex right there. Clean that up. There. That feels pretty good. The last thing I do is true up the bottom, because that's what's going to actually sit against the extruder. Okay, so there's a few holes on here that we need to do a little bit of work to. These two here serve two purposes. They actually hold the face piece on, and in addition to that, on the back, that's what's going to hold the spring in place that tensions the plunger that goes through the back. So we got to clean those out to make them accept the 3mm. There's another one under here that's also going to be a 3mm cleaned out hole, and that's what holds one of the bolt lugs that bolts it to the bottom of the bolts it to the extruder. The other one, the other lug or clamp, if you will, bolts on the side here, and two clean up, and then we're going to set a few things. So, and then the last hole here and the two up on here, we're just going to run that tap down and set them to accept the 3mm screws. So let me just run that down real quick. The only purpose those serve is to as a stop for the slide. But then the other one that gets drilled out. So this hole, and then there's another one on the actual slide carriage. They're actually the screws that hold the spring in place. Okay, so we're almost done with this. I still have to open up the 3mm hole openings. And that is this one. As you can see, I've made a few of these, so I'm pretty quick at jumping around through the setup. Okay, so there's a little bit more cleanup to do on this piece, and we're going to do that next in regards to where the Bowden tube goes in the bottom, and then also just to make sure that this opening is nice and clear and free for the filament to actually run through. So let me set that aside, and let's see what's next. Let's make sure. See, nice smooth action now. So that's all good to go. Let's see, let's go ahead and set the inserts and clean up this Bowden tube opening. So for that I have a drill bit the size of the Bowden tube. And I usually don't like to chuck it in the drill because it'll grab the filament and go too aggressively and pull it out. So I usually just run that in by hand, clean out that opening. And so that one's good to go. Now for this opening here, slides in and out, and this one, as you can see, is still pretty tight. It goes in smoothly, so it all depends on how your tolerances of your printer. So the first thing I like to do is to make this nice and square and true. So let's go back to the needle files and just give it a little dressing up. Like I said, there's a decent amount of cleanup, but it's not hard. It's just truing it up, clean it up, make it a little smoother, make it look a little nicer. The only thing that really matters is that a couple of these parts interact with each other accurately and don't hang up, and allow the filament to move smoothly. And you know, some of this is again purely cosmetic. You can clean these up with your choice of but not terrible either. So now, as you can see, that moves in and out really nice and smooth. Now this is another critical part. So if you think about it, and this filament gets pushed over, it normally is sitting, since I have it apart, you can see it now. The new filament is in this opening. Oops, I forgot to drill it out. Let me get that cleaned up first. So I have a drill bit roughly the size. It can be a little bit bigger than the filament itself. Let me open that up. Okay, so now you can see the filament slides freely. But this is what makes this device work so well, is the first filament, or the one that's running through the printer, is, if you can see, let me see if I can get up there close enough. There's enough gap that this filament can slide back and forth in that oval opening that's at the top. There we go, that's a little better angle. But at the bottom, it's only coming through a single hole. The next filament, and I'll just break a piece off. The next filament is going to ride in right behind it and sit, if I can get this at the right angle that you can see it, it sits behind it. Now, there's a mating pocket that is in the faceplate. I'm going to drop the nuts out that I put in earlier, that matches up with the size of the filament. So when these are bolted together, both filaments can slide smoothly in that oval pocket right next to each other. But obviously only the one can go through, the other one sits behind it. So what's going to happen is, if for those that haven't figured out how this thing works, when this one gets all the way past this shear point, or this perfect point right here at this base plate, that one then is out of the way, and now this one can be pushed forward right behind it, and because there's the perfect amount of gap in the faceplate, it can only go so far forward, and it lines up It sits in just the right spot. So if it's set too far, if this plunger pushed it too far forward, it would jam against the inside of this piece. So the easiest way to do that is I just hold it tight against the back, and as you can see, it's sticking out too far. I'll just file that down while I have it under tension. This is the part that takes a little fit and finish. When it's all bolted together, you run your filament through it, and if it doesn't work, you pull this plunger out, you give it a little filing, and then you put it back in. And then the other thing is, while I'm here, I just kind of smooth up the edges of the pocket so it doesn't bind up. And then this should be good to go. I'll just knock the high spots off the plunger. That should be pretty good. The next thing I like to do is I'll just take the round needle file. That's a square one. Where's my round one? Square. Yeah. And I'll just kind of twirl it in this opening to smooth up that pocket and make it more cone shaped. That'll allow the filament to slide down smoothly. As long as there's enough of a ledge that the new filament can sit on, it won't get down in that pocket and jam into the filament. Alright, so we're pretty much done with that. The next piece is the other piece of Bowden tubing. This is the one that's going to actually allow the filament to move smoothly into the extruder. So what I did with this is, and the length of it's going to depend slightly on the manufacturer of your extruder, how deep the pocket is that the Bowden tube goes into. So the way I get that prepped, and that seems to give it a really nice cone, gradual cone shape that eases the filament into the extruder. And then that can just slide up in place, bottoms out, and now as you can see, it just slides down. But you can see, I can feel there's a little bit of a lip there. You can't hear it or see it, but I can feel it. So when it pushes over, I need to make sure that that's nice and clear. So what's causing that is probably just a little lip in there, or just the end of this Bowden tube picked up some debris. So I'm just going to true that up a little bit. You don't want to press in, you want to make sure this Bowden tube's just the right length. You want it long enough that it stays in the extruder, doesn't have any play in it, but it's not pressing so much that it mushes up against the inside of that lip, causing it to curl over, creating an obstruction for the filament. Yeah, that's a lot better. And I'm still going to run the drill bit up through the entire assembly, fully assembled. That just ensures that it's going to work smoothly. Alright, so we're getting close to putting this all together. Back to the sliding carriage. There's two more openings I forgot that we have to tap out. So this is the swing arm, or the carriage swing arm. So that's just going to get drilled out. As you can see, that's why I made that hole in the back, to allow the tap to get all the way through. And then the same thing goes up here. Okay, that's done. So all these parts have been prepped. We have one part left to get ready to assemble the whole thing, and that's what I like to call the canary, because, well, it's kind of shaped like a canary. Again, smooth it up. Because that was right on the build plate. I opted to use a magnet, two magnets here for the spring tension, because A, it's very consistent, it doesn't get heavier as you load it up, but more importantly it was a space thing. To get a spring in here, I would have to use something like a bail spring on a spinning reel, and I didn't have access to one. I had access to magnets, and I like the idea of using rare earth magnets for small devices. So So again, there's a little fit and finish here. I'll sometimes file this after it's already assembled because when you see when this slides in, it has to move down. Okay. That shouldn't need much more than that, except for I have to drill out one hole. Again, the 3mm screw is going to go through there. Okay, so we've got that all done. We've got our springs. We've got all the various screws we need. Sorry, it's still getting a little messy here. I do use this long one just to melt some of the nuts and things into place and to put the brass inserts in. We'll get to that in just a minute. Oh, that's what we need to do. These two big holes right here, they're going to get fitted with these 3mm brass inserts. We could probably put a slot in there and drop in regular nuts, but I bought a bunch of these and I really like them. So all you have to do for these, if you haven't worked with these before, pretty easy. Just thread them onto the end of a long enough screw that you're not going to burn yourself. Heat them up a little bit. And then just press them in place and hold it until it cools. Done. These are, I bought a whole box of these on Amazon, I think, for $10. Okay, that one's done. There is another nut that gets set into the device to hold the bottom lug in. I went this route because this is probably holds the most, needs the most strength to hold the thing onto the extruder. Again, it all depends on how tight your tolerances are on your print. You may or may not need to open up the pocket a little bit or pull it in with heat. I tend to do it anyway, just because that way it kind of glues it in place without having to use cement. Doesn't hurt if it's set down in there a little bit. Just hold it for a few seconds. Alright, so that piece is almost ready to go. Let's go ahead and put the spring assembly and the plunger in. This one I use, obviously, the smaller of the springs, and I have all of these screws, their lengths, everything listed in the description where you downloaded it from. And for this one, we use these two medium length screws here and a couple of washers. I can get my fat fingers to pick these things up. Okay, that's one. Now for this spring, we're using a little different than a regular spring. I actually slipped the entire spring body right through the plunger, and then I'll put the other one on the same way. Well, that's 52 pickup. There we go. Okay, that spring is ready to go. Then this fits through the back of the body, and it just takes a little finagling to get it in there. But now they're in there, and you just got to get the washers clear of the spring shoulder. There we go. So that's how this spring is held in place. As you can see, it does a pretty good job. And then these same screws are going to, if you notice, that nut had to be in there beforehand because it's going to get blocked when we put this piece in place. So, and we can go ahead and put that in there now because we cleaned all this up. So let's just set this in place, run these screws in. Okay, and I usually try to just make sure the spring doesn't get pulled out of position. Now I'm going to have to Alright, so that is the plungers in place. Now I just need to make sure that the filament's going to run smoothly through it. So here's one piece, and it goes nice and smooth. Now I'll explain why this guard is here towards the end of the video. And then here's the next one. See, it doesn't go in, and if I pull back on the plunger, it now dropped in about 10 millimeters. So that's your new filament. I don't have the tension carriage in yet, but if I just push down on this, if I get to the bottom, it just, as you can see, it started down the path in the in there. So anyway, we're going to clean that out a little bit, make sure it runs extra smooth. But now comes the important part. We need to put the carriage together. So as you can see, it moves smoothly. I might sometimes take a little bit extra off of this bottom corner, just so that when the filament is a little easier. I could re-engineer that a little bit in the future design, but for now you just clean it up a little bit. Anyway, we'll get to the canary last. Let's go ahead and set the spring mounts. So those are going to be a couple of these, I think they're 12 mil? No, these are 10s. I think these are 10 millimeter long, or maybe they're 12. But there's a couple of these in here. Normally what I do is I will run a nut down them a little bit, and then I can run them in the depth of the body. Not that critical, it just has to be in there strong enough to hold it, just not long enough that it protrudes out and going to block the sliding carriage. So the other one, again, I usually put a nut on. Oops. Okay, so the other large spring, as long as you have enough room that you can get the spring hoop in there and it doesn't protrude past, you're good to go. Same thing over here. Alright, so again, everything moves nice and smooth. But now we have to assemble this canary. This is probably the single most, I won't say difficult, but the part that's the least just put it together. I'll show you where the magnets go in a few minutes. One goes in here, one goes on the back inside here. That's what causes these two parts to interact with each other, because they're offset to one another. So that's what causes it to pull in to the correct position. So, but there's one critical piece: the tooth that's going to grab the filament. This in this case it's ABS, isn't going to be able to grip the filament. To do is I got a hold of some sheet brass. Excuse me. I think this was not a 16th. It might have been 3/32. I think so. It doesn't really matter. You can make it with whatever you have. I had brass, so I used it. You could cut it with. I was cutting it originally with a emery saw on a hobby or on a moto tool, and then I realized if it's thin enough and you can get to it, you can just cut a piece off or bend a piece off by just using a pair of diagonal cutting pliers. If you can give it enough oomph to get it to break off. And then take a pair of pliers and fatigue it off. There you go. You don't need much of it, and we're going to cut it off in a minute, but this gives me a nice tab that you want to make it about the width, or this one's a little fat. So in the print, if you notice, there is a small little notch there. Let's see if I can get that to show up in the camera. You can see that little slot, right? It almost looks like a mouth below an eye on the, as I call it, the canary. What we're going to do is we're going to take this piece of brass, we're going to heat it up, and we're going to shove it in there and just let it cool in place. But before I do that, I want to give it just some roughing around where it's going to be shoved into the plastic, so that it has something to bond better. I can use a file, you can use anything. I just happen to have the motor tool sitting here, so I'm just going to use it since it's handy. Just giving it a little bit of texture to grab the molten plastic. And let's heat that up. going to insert. For the filament that heats up in a hot end, you would think it would just slide right in there with just a tiny bit of heat, but I guess it dissipates the heat really quickly. There we go. So just let that sit and cool, and just make sure it's square. And alright, so now that that's in there, all you got to do is take your diagonal cutting pliers again and nip off a piece. It can just stick out a little bit past, and this is a trial and error thing. If you don't get it right, just cut another piece of brass, heat this up a little, pull it out, put another one in. You'll see where it goes in a minute. In fact, I'll probably trim this a couple of times while we're getting this in here. So I'm just going to cut it off, and the diagonal cutting pliers do a nice job because they bevel it from both sides, which gives me like a need be. So now it's time to fit the magnets, and these are just two neodymium rare earth magnets. I think I bought a stick of them off of Amazon for $5 or $6. One, it doesn't matter what orientation you put them in, as long as they're going to find their own home. Obviously, if I put it the other way, it's going to repel it. So if you put this, or just hold this here, and then you put the other one on the underside, it will find its way. Oops, let me get that in there. You have something stainless steel that you can set it with. A lot of times, if you just have a tab, like this is obviously magnetic, it'll just hold it in there. And now that I've got that in place, they'll hold each other in place. But as you can, I'll show you why it's important about the size of this tooth right here. So for this one, I use a 10 millimeter. Again, another washer. Where'd my tweezers go? Okay. This is going to go through the eye of the canary. That's so wrong. I'm stabbing a canary in the eye. So, you obviously don't want it so tight that it binds. So just loosen up and see it. You want that nice spring action, but you don't want it so loose that it's flopping around. Excuse me. Okay, so right now I can tell you it's going to have to be trimmed. The reason being is, well, first of all, you want to make sure that the screw you put in here doesn't protrude far enough that it interferes with the back. Obviously, we're still good there. But as you can see, when this carriage comes down, it actually hits this little ramp, and it causes the little arm here to pivot slightly. And what that does is it takes the tension off of this little device. So, this is the only part. Sorry, my light keeps going out. This is the only part that really takes a little bit of time to get it just right. So, and as you can see, it doesn't have to protrude much. I'm just going to take a little more off. That's probably pretty good right there. Let's put it back on. And I may have lost my magnet because I usually like to leave it on the carriage. But as long as I get the magnet in there, or the one on the top, it'll stay put. Now we may have to do a little sharpening to that tooth to make it work just right. I'll show you that in a minute. So as you can see now, I've got a wider gap when it's not engaging a piece of filament. But I still have to make sure it's enough that when it comes to the bottom, see how it opens? Let me get that up closer to the camera. You see that little tooth right there? It opens. We can still take a little more off of it. So that's what I'm going to do now. Because be able to grip the filament, like right now I'm pulling back on it. That's the whole purpose of this ramp, is it releases it so the filament can move smoothly. So we got to take a little more off. I'll even use the Dremel tool to take the excess off if I need to. But sometimes I can just get it right. It's almost, if you just butt your cutters right up to the edge of the plastic, it's almost perfect. And then if you want to, you can always dress it up with just a little touch up. Important thing is you want the bevel underneath in this fashion, because if you think of how that tooth is going to grab, it has to grab it just right. And you want to be careful when you're using the moto tool on this, because anything that heats up that brass will cause that tooth to move. Okay. The other piece is where you first fuse it from melting it into this piece. I usually grind that off or file that off. Reason being is when it's against the sliding carriage, it can, or when it hits that ramp at the bottom, it can cause it to not bottom out fully. So I usually just make sure there's a nice no gap or no little lip of melted filament right there. Alright, let's see how we're doing. We're getting there. Maybe one more little polishing. See, it's down in between that tooth, and this is pulled all the way down, but it's still grabbing it just a little bit. So I'm just going to try it, almost butting up my cutters right to the edge of it and see what that does. That might be too much now, and then I have to put a new one in there. But maybe not. Maybe it'll be alright. I like the action of it. Obviously now we move nice and smooth, but now will it still grip the... Oh yeah, that's good. That'll work. Alright. So that's all put together. So I wanted to really make sure everybody saw how that little tooth works with it. But as you can see, there's really very, very little of that brass. It's only used to grab the filament once and then it pops out of the way. It's not like it's dragging along the filament the whole time it's running. That was the whole purpose of making it a swing arm, is it'll grab it and then let go of it, not just allow it to slide past it. So now that the carriage is done, we can put the main spring on. And I usually just twist it so that it's high on the one side, low on the other, so the spring basically sits almost flush. In other words, if you're looking at the spring, one of the hoops will be on the top and one will be on the bottom. But as you can see, as it comes down, it'll pull, and then that swing arm moves out of the way. Now, this little part here will take a little time to wear in, or you can just file it, but as you can see, it'll move on its own, given a little bit of time. And it's usually not that far. Usually there's a piece of filament there that's keeping it about there when it hits the bottom. So that's all good. Next we can the rail. So you have your choice. If you're mounting it on a Bowden tube setup, you can use just the straight one. If you're going to use it on a direct drive, you can mount this one on top. And that's what's going to keep the direct drive filament, the two filaments, the one on the old spool and the one on the new, in line with the top of the unit. Granted, it is a little harder to load the filament if you're doing it mid-print because the carriage is moving. If you're printing slow, it's not that big a deal, but if you're printing at any kind of speed on a Cartesian printer or on a direct drive, it's going to be hard to grab or get that filament in there. And the whole purpose of this is not to have to pause a print. So it's probably easier to use on a Bowden tube, but I use it on my Ender 3 all the time. Anyway, so let's go ahead. I'm just going to mount this with a couple more of the short screws. I think these are 8mm long, 3mm. Oh, I think I forgot to drill these out. I did. There we go. Yep. Missed a little burr there. Okay. We're getting close. And the last step I'll do on this is just, sometimes I'll just give it a little filing here. This lip and the tips of the screws don't quite, there's not enough depth. I guess I could have made the whole body just a little thicker, but it was kind of, the slide stop was an afterthought. I added it, or designed the whole thing, and then I added that at the very end. Past it. All right. So we're just about done. The last piece is the clamps. Excuse me, I gotta get my drink. Okay, so right here, this is where we just need to get some of the 8mm screws and washers. And I think I dropped one of them, so I gotta grab another one, because that one's too short. Let me... Where did it go? Oh. Just take one out of the previous one I had. There we go. Okay, so these, I'm just going to put them on for now, just so that the whole device is assembled and everybody can see it together. There we go. These are the two screws that go into those brass inserts we put in earlier. Okay. Now remember, there's a nut that's held up in place up inside here. That's what's going to interface with this lug. So the last screw we need is this one, and I think it was 18mm, if memory serves me correctly. And we're going to throw a washer on it. Oops. These washers are such a pain. Or it's my big fat fingers. Okay. And we put that guy in there. Alright, other than mounting it to the extruder, that's it for the assembly. Last thing I like to do is just take... I actually have one that's 1.75, and I'll just take it right up through the Bowden tube. As you can see, I'm pushing and it's kind of binding a little bit. So I'm just going to run it up through there. Wiggle it around a little bit. Make sure that the filament path is smooth and clear. And that's the installation, or that's the assembly of it. Let me just load it up with a filament. As you can see, it slides through nicely. And here's represents the new filament. You notice it's stopping right there. And I'm pulling back on the plunger, inserting it a little further, and then I should just be able to pull back on this gizmo right here. Now, because this is the direct drive, it's got this little thing in the way. So this is what I was talking about earlier. If you just slip the filament in there, it keeps it from falling out as the printer's moving around, so it doesn't pull it out of the carriage. But now, as you can see, it holds it nice and tight. And as I starts the new one right down in the path. If you're all wondering what is this bar and tab for, in my first prototype I found a problem where if the new filament was in this position waiting for the old filament to leave, and it got to the point where the old filament reached, say, this length, and all of a sudden a retraction happened, it would push back up on the carriage, potentially dislodging the filament or allowing the filament tension to be released, and then it could pop out, and then this carriage just popped to the bottom and didn't feed any filament. It obviously failed and didn't work. So the idea is, as soon as the filament gets once you have it load or mount the device and you load it, I always let the running filament run in front of this guard, because what happens is when this piece is up here, there's enough distance between the top of this, or I should say the bottom edge. It never retracts more than about 10 millimeters. I don't think anybody runs retractions more than 10 or 12 millimeters. That would be pretty excessive. And this has probably 20 to 25 millimeters of movement that it can move. So even if it has to retract several times, it's not going to push the carriage back up, because this filament is kept out in front, and then the one that's waiting in the wings, so to speak, is behind it. Sorry, it's hard to hold it all in place while you're, there you go. There you go. So as you can see, that holds it in the way, and then when this one comes down, it can't get to it unless, of course, this carriage isn't high enough. There we go. I'll just move this up higher. That's why it's important you always pull this all the way up, so it's waiting. So by the time the new filament starts down, it won't have enough filament there to cause a retraction to cause a problem. But again, I'll just pull this out. Part of this, give me a few minutes. I'm going to pause the video. I need to go take one of these off of the other extruder that I've been using as a test extruder. I'll be right back. And I'm going to clean up this bench a little bit. Alright, welcome back. A little earlier in the video, I showed you how I fully put the filament loader together. This is the extruder that I have on all my machines. It's available everywhere. Amazon, eBay, AliExpress, you name it. They're all the same. Some of them are mine. A couple of mine are blue, a couple are red. The only difference you have in them, if you look at the top, now disregard this little hole you see here. That one was from an early prototype where I actually drilled and mounted one of the first prototypes to this extruder, and then abandoned that because I wanted to make it that it would quick connect or just bolt on. So disregard that hole. The difference between these units is they either come with a threaded hole in the top to accept a Bowden tube adapter or fitting, okay, or they can come with just a hole in the top, much like this hole here. If it has just the hole, it doesn't mean it won't work. It just means you do have to drill that out the diameter of a Bowden tube, but you do not want to drill it all the way through. Because if you do, then the Bowden tube will just push down, and that's not going to work. It needs to act as a connector. The clamps keep it on the device, or the device hooked to the extruder, but without the Bowden tube it would move around and it wouldn't line up and things just wouldn't work. So it is critical that the device sits flush, but as you can see, this piece of Bowden tubing is still a little long. It's let me see if I can get you up there. It's about a little less than 1/8 of an inch too long. So I just have to trim it off a little bit. Either leave it bottomed, not too much. You don't want to push in so much that, as we talked about earlier, it curls over that cone-shaped piece that I trimmed. But all I'm going to do is take a hobby knife, a little block of wood right here. I'm just going to set it down on the block of wood and trim off that distance or that amount that I saw that was a little too long. Try to get it as square as possible. It really shouldn't matter too much, but as long as it's close, it should be good. And then I'm going to test fit it again. Make sure it sits flush, and it's still just a hair too long. So one more time. Like I say, there's only 3 or 4 critical measurements, pieces in this whole thing that have to be really spot on to have this thing work right. That should be okay. And again, a lot of times I'll run that small drill bit up through it just to make sure that the Bowden tube is nice and clean. I can actually, it's not going to hurt anything to actually twirl your knife in there a little bit on this section as well, just to clean it up. Alright, so now when you put it, see, now it sits nice and flush and flat. So ready for the next step, which is to just, and oh, by the way, you don't have to take the swing arm off. You can if you want. You don't have to. This piece is made to just sit, and it locks underneath. It's shaped to lock underneath the swing arm exactly. So, oops, if I get the right tip in here. There we go. So as you can see, it's already on there, except it's not as solid as it should be, and that's where this block comes in. So this slips around the spring. And the measurements on the bolts in the documentation, it's critical because if it's too long it would go up and interfere. But as you can see, once that's locked in place, it's not going anywhere. It's latched in there real nice. Let me get a piece of filament here, and if I slip it down through the opening, I'm against the rollers. As you can see, it feeds. Oops, let me get that a little closer. Let me do that again for you. I'm just pushing it through and right on through the system. Okay, so there's your one filament, and let me get another. Well, actually, let me get another piece that's longer. There we go. Got a piece of red. So I'm going to put the new piece in behind it. I'm pulling back on the plunger, pushing down on the filament, and then if I want I can hook it in there and then just pull back on it. And it's locked and ready to go. And again, I'm going to just take the tension off of the feed rollers, and then I'm just going to pull this through. As you can see, it pushed all the way down. It still has another probably 15 millimeters or 10 millimeters to go, but it's already past the feed rollers. And it'll just keep on pushing right down through. The feed rollers already have it, and we'll grab it and pull it through. But if you noticed, when it got to the bottom, that little, what I call the canary, released because it hit the bottom of the ramp and went from a gripping location to a completely out of the way, free moving. And then you can just take, once the filament has changed rolls, and this is now becomes the running filament, you can just lift it and put it in front of this guard stop, or this little nylon or Bowden tube guard, and then that way you could just queue up another roll behind it, and then it's ready to go for the next roll. So it really works well. Again, it's easier on a Bowden tube setup than it is on a direct drive, just because when the direct drive's moving around, you kind of have to get it in there and operate this while the carriage is moving, and it's doable. I've gotten pretty good at it, but again, it's the option of, oh, I'm going to run out of filament, I lose a whole print, or I can continue my print. I'm willing to put up with a minor one or two blemishes while it's moving around if I accidentally bump the carriage to save the print. Now on a Bowden tube, that's not even an issue. So anyway, I'm going to go ahead and stop the video again. I'm going to go set this up over on one of my printers that has the, it's set up to take another extruder, and I'm going to go ahead and set it up and let you see how it actually operates. But this is the same unit you saw me assemble a little while ago in the video, and you saw how much work I did to get it cleaned up. It wasn't a whole lot. It took me about half hour, and I was recording this video at the same time. So give me a couple minutes and we'll be back. Okay, so welcome back. What I've done is I've mounted that same extruder we put together on the bench a little while ago. I've already put a piece of filament in it through the extruder. That's this yellow piece you see here. I've got a few other pieces, green, orange. These are all brand new pieces of filament. I just cut them off a spool. And I'm just going to go ahead and load it into the device the way I showed you in the when we had it on the bench. So I've pushed it down, I've pulled the tab back, bottomed out the filament, and then I'm just going to hook it, since this is the one I made for my direct drive, I'm going to push it into that little keeper, and then I'm just going to slide this little carriage up. And if it doesn't grab, you can just give a little tension on it right there. So now it's sitting there primed and ready to go. I'm going to start, and I'm going to initiate an extrusion. So let's go there, extrude. And as you can see, the yellow is now making its way through the extruder, and when it passes this point, it's now passed far enough that a retraction wouldn't cause the carriage to interfere. So it just passed the shear point, and now you can see the green filament is coming down, and it's pushing right on through, and it is right behind the yellow. I'm going to go ahead and just take this piece of orange you see, and since the green, I only did a 50 millimeter extrusion, I'm just going to load up the next piece by taking the green one, which is now the running filament, put it in front of that little guard, put a new piece in, pull back, set it in the keeper, slide this up. Let's fire another extrusion. And there we go. And there you have it. So it does work. It's repeatable. I've done as many as 6 different small pieces of leftover filament, and I just would load up one right after the first one, was getting close. I don't see a point to load up the second one like for when you have a whole spool in there, but it definitely, as you're getting close to the end, you can just queue up another one and it just keeps on printing. So it definitely works, and I hope you guys enjoyed the video.